All right, so we're going to simplify rational expressions. Some rational expressions you can already simplify. For example, 10 divided by 6 reduces to 5 over 3, simplified, done. But another rational expression, x plus 8 divided by 10x, not necessarily so easy. Or another rational expression, 4v squared over v squared minus 9. Also not quite as easy to work with. So how would we first look to work with these kinds of numbers? Well, the first thing we have to do is we have to look for excluded values. And what that means, and it's super duper important. In fact, I'm going to change this symbol because the symbol I always use is a giant fat semicolon. It's sort of like, okay, we're going to have to look for those excluded values. Super important. So what is an excluded value? Well, if I wrote the fraction 2 over 0, you would know immediately that's undefined because you can't ever have 0 in the denominator. But if I write the fraction x plus 8 over 10x, that's this one here, you don't necessarily automatically go, wait, that's undefined, because it looks perfectly natural and normal. It doesn't look like a 0. But in fact, you have to look first, and that's where the fatty semicolon comes in. You have to look for whatever x would make the denominator equal 0. So the denominator is not allowed to equal 0, which in this case means x is not allowed to equal 0. So now I can plug in any value for x, and I may not like what I get, but at least I know as long as I don't choose x equals 0, I'm not getting 0 in the denominator, and it's totally legal. So let's look at this other example. 4v squared over v squared minus 9. Whenever you have a rational number, you should first think instantaneously, caution, mayday, mayday, v squared minus 9 altogether can't equal 0. The denominator cannot equal 0. So now we have to find what would make v equal 0, or what v would make the denominator equal 0, and we have to exclude those. So in this case, we're looking at a quadratic, which means I have to factor it. And luckily, it's a mother's face, so it's super easy to factor. And then the zero product property says that v cannot be positive 3 and v cannot be negative 3. Then if you keep working with this and at the end, you end up with, oh, v equals negative 3, you'd have to come back up here and say, but that's not allowed. And so this polynomial, or excuse me, this rational number has an excluded value or is an undefined rational number. And then the next thing we want to look at is just simple reducing. Now the good news is it may not be as easy to see as it is when you're dealing with a fraction like this, 10 over 6, but reducing a polynomial expression or a rational number involving polynomials is just the same process. For example, if I'm given the polynomial, or excuse me, the rational number 2x over 3x, I really want to write everything as a product of primes, so the integers are super easy. 2 and 3 don't reduce, but this is really 2 times x over 3 times x. X over x is the same thing as 1, and so this reduces to 2/3. So I'm able to reduce that variable right on out of there. What about an example or a situation where I have something like 6x in the numerator and the denominator is 6x plus 30? Well, same thing. I'm going to want to factor the numerator completely. So I have 6x, and we don't, in pre-algebra, we used to have to write 6 as the product of primes, 2 times 3, and then 6 down here again if I did that. But we don't do that in Algebra 1. It's expected that at the end, you're able to reduce integer values on your own, the same way as here I easily saw they both divide by 2 and did that reduction. So we no longer reduce the integer parts, but the variable parts we do. And then in the denominator, we want to factor this. Well, ME says I can factor out a 6, and that leaves me with an x plus 5. Also notice that when I factored this, I didn't have to use all of my shortcuts and helper steps for ME. If you're still using those, that's perfectly fine, but you should start doing those now on scratch paper or off to the side of your work, because it's not really part of our problem anymore. We've already learned how to do that, and you're just developing the skill. You're just improving the skill. You're not developing the understanding. And then technically I should be working down the page for all of these, but for a lesson, it's just too hard to do it without using up just pages and pages of work. So 6 divided by 6, that equals 1. Those factors cancel, and then the final answer is x over x plus 5. So that would be reducing that polynomial. So now let's do some examples where I work down the page. Notice I always use white when I'm doing examples that look like I want your work to look. So let's do 8b squared plus 16b over 32b. Okay, so I want to factor the numerator and then factor the denominator. And I'm going to go off to the side to do that. This would be my scratch work area. So I have 8b squared plus 16b. First, let me say, if you can do this in your head by now, and you know that 8b divides both of these terms, and you're left with a b plus 2, then you should just do that. There's no reason to show me this work anymore. You've already learned this process. Now you're just developing and improving your skills. So if you use scratch work on the side, that's perfectly fine, but it's no longer a part of your problem. So I know that this divides by 8b, as does this. That's the biggest number that divides both. If I ME the 8b, what do I have left? Well, these cancel, right? And I'm left with a b, plus 16 divided by 8 is 2, and b divided by b, those cancel. And that's exactly what I got here. So you should be doing these methods as scratch work now while you get better at factoring. And then as soon as you're good at factoring, then you're good to go. So 32b. All right, so what do we have? Well, first off, we have the integer over the integer. How does that reduce? 8 divided by 32 is really just 1/4. So I know I'm going to end up with a fraction. That's 1/4. B divided by b, the two b's are definitely going to cancel. And so what's left in the numerator is just b plus 2. So 8 divides with 32, leaving a 4. That's why 4 in the denominator. The two b's canceled, and I'm left with b plus 2 in the numerator. Let's do another example. Let's do a over 1 minus a over 1 minus a. So in this case, I want to do just as before. I want to factor both. So fully factored numerator is just a. That's all it is. I can't do anything with that. I could write it as a times 1, but then I'd have to say there's 1 and a 1. It's the trivial factor that we don't write down unless we need to. And then in the denominator, 1 minus a. Well, this is a binomial, and there's nothing that I can factor out. There's no greatest common monomial factor. So fully factored, the denominator is still 1 minus a. There's nothing I can cancel. Now, you're going to want to do this and think you're good to go, but that is never, 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 never allowed. All right? Because 1 minus a is a number. Canceling the a's in this case would be like if you had 4/5 and you said, well, this part of the 4 could be like this part of the 5. I'm going to cancel that, and I'm left with 1 over dash and a little thing. That's obviously insane. Nobody would do that. And really, that's the same thing you're doing if you do this. So do not do that. All right, let me go back. I'm going to erase that because that's so crazy. I'm not going to leave that there. I'm going to go back and do something that would have been done immediately, but I wanted to make this point first. So when we got this original problem, before I factored and did everything else, I was going to, or I should have, made sure I checked for excluded values. So I know that 32b, which is the denominator, cannot equal 0, which means if b equals 0 in my final evaluation, I have to throw my answer out. That's an extraneous value or an extraneous solution. And here I would do the same thing. I'd say 1 minus a cannot equal 0, which means that a cannot equal, what would that be? 1 minus 1. A cannot equal 1 because 1 take away 1 equals 0, and that would be never allowed. Let's do a couple more complicated examples. At first, you might have a little heart attack when I write them down, but you'll see pretty quickly that you're totally equipped to do this. We want to simplify x squared plus x minus 12 and x squared minus x minus 6. First thing, caution, always caution, caution, mayday, mayday, Will Robinson. X squared minus x minus 6 can never equal 0. Factor this, x minus 3 times x plus 2 can never equal 0. And so x can never equal 3 and x can never equal 2. So now I know the excluded values. I'm going to go ahead and simplify this. First thing, I have to write them all in factored form. The good news is I've already factored the denominator. So let's factor the numerator. X, well, two numbers that multiply to give me negative 12, but add to give me a positive 1. That must be 3 and 4, because 3 times 4 equals 12. And to get a positive x, it would have to be a negative 3 and a positive 4. Over, I've already factored my denominator, x minus 3 and x plus 2. Now I can keep going. X minus 3 over x minus 3, that's just 1, right? Factor over factor, same factor in the numerator and denominator, just as 1. And so my answer is x plus 4 and x plus 2. Now, you got to be careful. At this stage, you might want to say, well, then it's okay if x equals 3 because I canceled it out anyway. That's not true. Even though plugging 3 back into this would give me a totally legal outcome, 3 plus 4 over 3 plus 2. 3 plus 4 is 7, and 3 plus 2, though badly written, is 5. 7/5 is perfectly fine. 5 is not 0 in the denominator. We have to remember that this is simplified from this. And so whatever is not allowed in the original is not allowed in the final answer either. So let's do one more because these are totally fun. X squared minus 7x plus 10 over 25 minus x squared. First things first, 25 minus x squared is not allowed to be 0, which means I'm going to add x squared to both sides, which means that x squared is not allowed to equal 25, which means that x is not allowed to equal plus or minus 5. So notice this time I use the square root property instead of factor and ZPP. No big deal. I just know that I'm not allowed to have a plus or a minus 5 for my x value in my answer because that would give me a 0 in the denominator. Now let's go ahead and factor. The numerator factored is, let's see, x minus 2 times x minus 5. So negative 5 times negative 2 is a positive 10. Negative 5 minus 2 is a negative 7. So I'm good to go there. And now look at what I did. I took a shortcut, and in the end, I'm going to have to factor anyway. That's okay. It's a mother's face. It's super easy. 5 minus x and 5 plus x. Now notice that I almost have factors that can cancel, but let's take it off to the side where it's easier to see. What I'm really looking at is x minus 5 over 5 minus x. And negative is not commutative, right? 2 minus 5 is not the same thing as 5 minus 2. And so I can't really cancel, but I can notice that If I wanted to, I could ME a -1 out of both of these. And if I did, I would get a -1 times 5 divided by -1 is -5. Negative x divided by -1 is plus x. And then if I just rewrite the order, I get x minus 5, which is exactly what I have in my numerator. So this is just an opposite, right? An opposite of a number. The opposite of 2 is -2, and the opposite of -2 is 2. Same thing here. The opposite of x minus 5 is minus x plus 5. Whoa, that's not right. Let me back up. The opposite of 5 minus x is minus, change the signs of both of the parts. Positive x this time minus 5. And the opposite of minus x minus 5 would be distribute. So now it's a negative x and a positive 5. So this is just an opposite value, which means I can rewrite this whole thing now. X minus 2 over x minus 5 and minus x minus 5 times 5 plus x. These can now cancel, and my final answer, x minus 2, the whole fraction is going to be negative, and I'm going to rearrange these. I can switch 5 plus x because that is commutative. So x plus 5. And I don't really need those parentheses. So that's it. That's dealing with rational numbers. You're dealing with fractions, only they're bigger, uglier fractions.